So our next section is on inverse. So y equals b to the x was our exponential function, and it has an inverse function. It's found by switching the x and y. So you can see we switch x and y, and then we solve. To solve, we have to use logarithms. The abbreviation for logarithm is just log. So you can see, in order to get this y by itself, we actually took the log of both sides. And that's how we wound up with y equals the log base b of x. I'll say that again. Y equals log base b of x. And the key parts to this, b cannot equal 1. This value cannot be 1. And it must be greater than 0. Therefore, b to the y equals x. B to the y equals x requires x to be greater than 0. So log base b of x is defined only for x greater than 0. Here's a few examples. Write each exponential equation in logarithmic form. So, in order to do that, let's write below x equals b to the y. And that goes back to what we had written up here. And we know x equals b to the y translates to y equals log base b of x. Another way to think about that expression is to say, okay, y is the power you raise, the power you raise b to get x. See, y is the power you raise b to in order to get x. So we could think about it by replacing each number with a variable and then rewriting it this way. So we would, the 2 is in the place of y, so we put a 2 here. And then we write log, and the b is a 10. 10 is in the spot for b, and in the spot for x is 100. So you can write it using the definition. You could also write it using my phrase here. 2 is the power you raise 10 to get 100. 2 is the power you raise 10 to get 100. Ooh, sorry. That should just say 100. The x just goes right here. The 10 is a subscript. So log base 10 of 100 equals 2 is the same as saying 100 equals 10 squared. We'll do another one. Again, we could write our variable expression below, our definition. So we have y, the 4 is in the y spot. And then we have log base b, log base, so 3. And then x is 81. So 4 is the power you raise 3 to get 81. 4 is the power you raise 3 to get 81. So these would be our solutions. Try part C on your own. Rewriting that. Example 4. Evaluate each logarithm. So log base 2 of 8. So what is the power you raise 2 to get 8? Well, 2 to what power? 2 to some power equals 8. 2 to what power equals 8? Well, 2 times 2 would be 4. 4 times 2 again would be 8. So 2 to the third is 8. So our answer here is 3. Now we have 7. 7 to some power is 49. So 7 to what power is 49? So hopefully we know our perfect squares, and we could say, well, 7 7 to some power equals 49. Well, that'd be 7 to the second power. So 7 to the second power. These are not, you cannot easily enter these into a calculator. So it is actually that we keep them at a level that is simple enough for you to do simply by writing it out and thinking through your the values that you know to be true for exponents. And part C, I would like for you to try on your own. In our last example for these notes, solve for x. So 2 is the power that you raise 3 to. So step 1 is just to rewrite using exponents. And so I would say, okay, so 3 to the second power equals x. Step 2 would actually just be to simplify. What's 3 squared? It's 9. So that's your answer. For part B, 4 is the power you raise 5 to get x. So step 1 would be to rewrite. 4 is the power you raise 5 to. So 5 to the 4th equals x. So step 2 then would be to calculate what is 5 to the 4th power. 5 to the 4th power, and you can enter 5 to the 4th power in your calculator. 5 to the 4th power is 625. I want you to try part C on your own.